So what I'm going to do now is I'm going to walk through some preliminary feedback for assignment 1B. Your 1B initial submission is due in a couple of days, and I'm going to give you some tips on what not to do in order to make sure that if you want to try to address these tips before I review your code, you're likely to do a better job for the initial submission, which is always good for all of us. So first of all, please make sure that you run your code and document your code. So make sure you run the unit tests. Those unit tests are designed to help you find problems in the code before you submit your code, before we have to review it. So make sure you run those unit tests. Make sure you take a look at the output. Make sure you understand what's going on. And if you have any questions, please feel free to post them to Piazza and/or come to office hours and we will help you. Also make sure you comment your code. Some of the code is pretty subtle. So if you comment your code, then I have a better idea of what you think you're doing when I review it. So now let's take a look at some of the problems. So this is for the grad student version. Something important is missing here. This is going to be null, because remember that reference types are given null values if you don't explicitly initialize them. So you'll get a null pointer exception if you try to access this. This again is also for the grad student version. Make sure that you use the proper syntax, because atomic reference is a generic type. And so you have to make sure that you properly use the syntax to indicate it's a generic type of things that hold threads. You don't need to use atomic integer in either the reentrant spin lock or the spin lock. Just use an int for the reentrant spin lock, and then you'll make sure that you access the values in such a way where there's never any contention for it. Let's take a look at the try lock method. This again is the grad student version of this. So this code is too complicated. It needs to just basically check to see if the lock is currently held using the underlying compare and swap operation called compare and set that's part of atomic reference. So you can simplify that code. This is kind of the classic mistake of implementing try lock. This is exactly what not to do. You don't want to check to see if the lock is currently owned, and when finding out it's not owned, then set it to the current thread. That is just the classic race condition waiting to happen, because it's not atomic. There are two operations that are not protected. And so as a result, there's a window where race conditions will sneak in when you least expect it and when it's most inopportune, and chaos and insanity will break out. So instead, obviously, you want to use the compare and set operation. You don't need to use a loop to do compare and set. It's just a simple call. There's no need to loop in try lock. You're just doing a one-shot test to see if it succeeds. Here's now the lock implementation. Once again, you don't want to have multiple calls here. You don't want to check to see if it's null and then set it. That's going to be causing problems with race conditions, because there's a window where two threads can come in or three threads can come in and cause havoc with your atomicity properties here. So definitely do not do that. This code, this is very subtle code, very subtle bug here. We'll talk a little bit later about optimizations for acquiring for trying to acquire locks using compare and sets in loops. And the trick is, it's usually a good idea in order to first check to see if the object's value is null, and only try to acquire it if it is null. And the reason for that is it has less overhead with the bus caches. And I'll post a link to the Piazza discussion forum explaining how and why that is. It's really cool. But this particular code has got a bug, so don't write code like this. And it's very subtle. Here's another issue. This again is for the grad student version. Please use the equal operator instead of using the equals method. It's just a little bit more concise, and we don't need to make the call to equals. Please get in the habit of using plus plus or minus minus instead of plus equal or minus equal. Down here, Don't make the call directly to compare and set inside the while loop for lock. Instead, what you want to do is use the try lock method and make sure you also carefully check to see whether or not the owner of the lock is either null or false, depending on which version you're doing, grad student, undergrad version. But call the try lock method instead. So the try lock method instead, and that is there to help refactor out common code. There's no need to do this complicated boolean.false.equals. Just use is cancel.get and then treat it in the appropriate way. And there's no need to call try lock again. That makes no sense. It's not even having its return value checked. Here's an important thing to remember. Unfortunately, there's no easy way to auto test this with the unit tests, but after you do the compare and set via try lock and it fails, in other words, somebody else is owning the lock, it's a good idea to call thread.yield. And that says, anybody else who's trying to make progress is free to run. I won't just sit here and compulsively spin, locking everybody else out from making any progress. So it's just a polite optimization that lets the other threads get a shot at trying to access the lock. Now, that may or may not help them, but it just is a way to not hog the core. If unlock is called and the owner of the lock, owner of the lock is not the calling thread. In other words, if you're trying to unlock a lock that you don't own, then you need to throw the illegal monitor state exception, because that's a bad thing. Trying to unlock a lock that somebody else owns is a problem, because these kinds of locks are so-called fully bracketed locks. The intent is that the thread that acquires them must be the thread that releases them. And again, use hold count minus minus, not hold count minus equal 1. Here's some other issues. So you need to make sure that you properly throw the illegal monitor state exception if the lock is not held by the owner. And this will also give you a hint as how to check that atomically as well. Now let's switch over and start talking about the spin lock hash map manager. So make sure that you define your fields as being private, not public, because otherwise the unit test will yell at you and the error message is a little bit confusing, but such is life when you're doing mocking. Here's some things with the build model method, which is kind of a virtual constructor. As a general rule of thumb, please get in the habit of using the for each method and the lambda expression instead of using a for each loop. Just a good thing to learn. The code here is not wrong. It's just a good idea to learn how to use the functional programming features wherever possible. And also make sure you give the right value to the semaphore constructor. Giving it the value of 1 makes no sense. It should be the number of palantiri that the system has been configured with based on the options that were given through the GUI. And there's a method that gets the palantiri count that you should call in order to get those results. Here's some other problems. So this code here doesn't even work because it has no terminal operation. If you're not a Java Streams aficionado, don't worry about that. Just use a for each method, as we've said before, to get this to work. There's no need of doing stream and map and everything. That's wrong and more work than you need to do. Also, the goal of the build model method is to initialize the various fields. So initialize the map, initialize the semaphore, initialize the spin lock, and so on. And so make sure that you do that properly, and make sure that you don't try to call methods before they're initialized. Oh, something else I should point out. Let me go back up here real quick. When you define the spin lock, sorry, I think this is actually in here. In addition to defining this as private, not public, also make sure that you use the super type here, not the subtype. So don't define this as spin lock. Go take a look and see what type spin lock implements and make sure you use that type instead. And that's just a good habit to get into when writing Java code. It's a good idea to use the super type as opposed to the subtype whenever possible, because that gives you more flexibility in being able to have different implementations without changing your code by using one of the fundamental principles of object-oriented programming. All right, so let's continue on down here. Now we're getting into the fun stuff, the acquire and release methods. This is where the bulk of people's problems probably lurk. First of all, you don't need a loop in this way. You don't need to be calling is canceled in this way. That is handled differently. Make sure that when you call lock on the spin lock, that you're passing in the appropriate parameter. And I'll give you a hint. False is not the right value, and null is also not the right value. Instead, what you're going to need to do is pass in a method reference to a method that checks to see if the cancellation has occurred. And that's a big hint. It's very straightforward, but you just have to pass in the right parameter. You don't need to make these checks to see if the state is blocked. I'm not quite sure what that's trying to do, but you just need to call unlock. But you have to make sure that unlock for both acquire and release is properly called in the finally portion of a try-finally block. Get in the habit, please, of always calling unlock methods in the finally portion of try-finally blocks. And whatever you do, don't be calling the release method in acquire. Don't be releasing the Palantir semaphore, because the whole point of the spin lock hash map manager, or any Palantir manager for that matter, is to make sure that we're blocking such that only n number of threads will be able to gaze in the Palantir, where n is the number of Palantiri that are available. So if you release the semaphore, then chaos and insanity will break out. This is some other things. Don't be trying to call try lock here. You want to call lock, and make sure when you call lock that you pass the right parameter. This code won't even compile because there's no way to have a call to lock that doesn't pass a parameter to it. When you pass the parameter to lock, make sure you pass it as a method reference, not a Lambda expression. Just get in the habit of simplifying things. And then some people are, kudos to them. They're doing some really nice work with streams here. And this is cool, really fun. If you do it right, it makes the code more interesting to read, if nothing else. But you also have to make sure you do it correctly. So one thing you'd want to not do, don't use key set if you're doing the streams approach. Use entry set. And when you use entry set, then you're going to filter for the value in the entry set to be true. And at that point, then what you need to do after you found something that matches that, then you need to have a map call. And that map call needs to replace the value of that entry set with true, or with false rather, because it's no longer available, whereas previously it had been true. And what you do not want to do is you don't want to be calling methods like get or put, as you see down here. And the reason for this is that you don't want to be doing additional hashed lookups in order to take the Palantir and go back and hash and then change its value that way. Once you've found an entry that has a true value, you want to take that entry and set its value to false, and that won't require any further lookups. So there are two ways to do this. One is to do the Java stream approach here, and those of you who feel comfortable with streams, I highly encourage you to figure out how to do this because it's very cool. For those of you who don't feel comfortable with streams, not a problem. Just use a for each loop that iterates through the entry set and then checks each entry to see whether or not its value is true, and if so, change its value to false. So that's another way to do it. Not quite as cool, but since we haven't formally covered streams, I don't expect people to know them unless they've learned it through some other means. Let's now go take a look at release. So there's a bunch of different things down here. You don't have to check whether something's interrupted. Always check first to see if the Palantir is null and bail out if it is, because you don't want to be trying to release a null Palantir. That'll cause lots of problems. This particular check, some people are doing this, isn't quite right because you can get back a false. You can also get a false instead of a null, so you need to change the way that you do that expression. Likewise, please refactor your code so that the unlock method on the spin lock is only called in one branch. You may have to do a little bit of refactoring to get that to work. And you should also always make sure that unlock is called in a finally block. So make sure that that happens through hook or by crook. Here's some other problems. If the Palantir value is null, do not call release because someone gave you an invalid Palantir. We need to do some sanity checking on the Palantir that's passed in because we don't have any control over it. Someone can pass in a null or some nonsensical Palantir value. So there's a couple things we have to do to make sure we get the right value. So whatever you do, don't call release unless you know you have a good Palantir. And don't write code like this that is going to be full of race conditions. You want to use atomic operations like put or replace that are atomic, and you don't have to worry about the issues there. Down here, make sure that you move the call to lock before the try block. And that's important because if lock was to throw an exception for some reason, then the lock would not be held, and we don't want to be trying to release it or unlock it in the finally block. So make sure you move that call outside of the try block. You need to make sure that the replace or the put method, whichever one you choose to use, they're basically the same, that you get the return value from that and then do something sensible. If, for example, replace or put fails because the Palantir was incorrect, then you want to make sure you don't release the semaphore. You always want to release the spin lock, but you only release the semaphore if you have a valid Palantir. You don't need to check whether the spin lock is null, and make sure again that you call the unlock in the finally block, and also make sure you only release the Palantir semaphore if the put or replace method succeeded. And so I don't want to give it away totally, but you'll have to figure out what it means to succeed. But those are some of the things that you need to think about. If you don't get these things right, then the unit tests will yell at you, quite rightly, because it's incorrect code. And sometimes the unit test error messages are a little bit hard to decipher. And that just is the limitations of the mocking framework that we've got here. It's quite powerful, but sometimes the errors are a little bit more obscure than we would like. But oh well, that's what happens when you're trying to use a mocking framework to do concurrency control violations and detect race conditions through mocking. So that's an overview of this particular set of frequently made mistakes. I strongly recommend you take a look at this stuff and then make sure that you update your code accordingly before you push it and submit the Google form.